This is our mini unit, M-I-N-I, mini. There's only 3 sections in it. We call it chapter 0.5 because we are putting it in between chapters 1 and 2, or yes, chapter 0 and 1. So it is 0.5. And we will be talking about solving systems of linear equations by graphing. So, first of all, just kind of to remind ourselves, we are looking for solutions. And when we're looking for solutions of a system, that means that we are looking for an ordered pair. So we're looking for an x, y that satisfies each equation in the system. Now, typically when we start with systems, we do 2 equations, like on example 1 down here. But systems can have 3, 4, 5 different equations, and whatever the solution is, that has to satisfy all of the equations in the system. So, to kind of give us an idea of making sure something is a solution, we want to check to see if something, this point right here, 2, 2, is a solution to the system. So in order for it to be a solution, it has to work in both equations. So I want you to hit pause, substitute 2, 2 into both equations, check it out, see if it works. Then go back and do the same thing for 0, 1. Put 0, 1 in for x, y in both equations, see if it works in both. And then come back and check your answer. All right, so we're going to check 2, 2 by substituting 2 in for x and 2 in for y. That gives us 6 minus 4, and 6 minus 4 is 2. So it works in the first equation, but there's no guarantee that it works in the second. We have to check both. So we substitute 2 into that second equation as well, 2, 2. And we find out that it does work in both of those. So our conclusion is 2, 2, whoops, parentheses, is a solution. All right, now let's check to see if 0, 1 is also a solution. I'm sorry, 0, negative 1. So we'll substitute 0 in for x and negative 1 in for y. And we get 0 plus 2. All right, so it works in that first equation, that's good, but we have to double check, make sure it works in both. So we substitute 0 in for x and negative 1 in for y. And we end up with negative 2 equals 6, which we clearly know is not true. So that tells us that 0, negative 1 is not a solution. All right, so that's how we take a system and test to see whether or not it's a solution. Next, we are going to look at how to solve a system by graphing. There's multiple ways to solve a system, and we'll go through lots of different ones, but we're going to start with graphing. Both of these equations that they gave us here are in what we call standard form. Now you can manipulate them to put them in slope-intercept form, or you can use the quick way to graph standard, which is by finding x and y intercepts. So you substitute a 0 in for the x. That gives you negative 3y equals 1. Divide by negative 3. We find out that our y-intercept is negative 1/3. You can do the same thing for the y. Substitute a 0 in for the y. So that gives us 2x equals 1. Divide by 2. So our x-intercept is 1/2. Then we can do the same thing for the other line. Put a 0 in for x. That tells us that y is going to be 3 for our x-intercept. Put a 0 in for y, and x is going to be 3. It's always good to find all of those first before you start graphing, so you can figure out what your scale is going to be. Looks like I'm going to be counting by halves and thirds. So I may or may not want to count by 1. I could, but then we'll just have to have some fractions in there, kind of guessing where it's going to go. So just kind of up to you. Go ahead and try to figure out a scale, graph it, and then come back and see if we have the same looking graph. All right, so I'm going to count by halves, which isn't going to help for all of our fractions, but maybe it'll help for some. So we have, this is the easiest one to graph here. Point at 3, 0 and 0, 3. Always use a straight edge to connect those points. And then our first one, we had a point at 1/2, 0, and then -1/3. So right here would be -1/2. That's -0.5. -1/3 is 0.33, so it's going to be slightly less than that. So that one is kind of an estimate. It's hard to tell exactly where it's going to go. And we'll line those up. Something you will quickly learn about the graphing method is it's not very accurate. It's sometimes hard to tell what our answer is. We are looking for where these two are intersecting each other. So I'm going to say, because most of the time it's usually integers, I'm going to say it looks closest to 2, 1. But mine didn't cross at 2, 1, so I don't really know if 2, 1 is the correct answer. So I'm going to use that same method that we used on the first one, where I substitute the points in to both equations to see if 2, 1 actually works. So when it says check your answer, I'm going to take 2 times 2 minus 3 times 1. We have 4 minus 3. So it does work in the first one. That's good. And then 2 plus 1 equals 3, checking it in that second one. And it works in that one. So 2, 1 is the solution. And maybe it crossed exactly at 2, 1 on your graph, but it is hard to tell when you're graphing where it crosses. So it's always important to check your solution after you find it. All right, so we want to do the same thing on example 3. We have a system on A. We want to graph it by finding the x and y intercepts. Same thing on B, finding the x and y intercepts and graphing it. So go ahead and take some time to do that. Hit pause, find your x and y intercepts on this one, graph it, figure out what your solution is, and do the same thing for part B. Then come back and check your answer. All right, on part A, we have 0, -3 as our y-intercept and 2, 0 as our x-intercept. For the second line, we have 0, -3 as our y-intercept and 2, 0 as our x-intercept. You might notice something interesting going on there. So we have 1, 2, 3, 0, -3, counting by ones, and 2, 0, counting by ones there. So this bottom line is the one I graphed first, trying to keep my colors going so you can see the red points are this red line right here. But then when I graph this one, 0, -3 and 2, 0, it's in the exact same place. So when I draw that line, it will be the exact same line. You may or may not remember what that means when you have the same line. If we're looking for solutions, solutions are where the lines intersect each other. Well, they're intersecting each other everywhere. So we use the term infinitely many solutions, which you can abbreviate IMS, because as long as the line continues, all of the points on that line will be a solution. All right, let's look at B. For B, our first line has a y-intercept of 0, -3 and an x-intercept of 2, 0. You might notice it's the same line as over there. But our second line has a y-intercept of 0, -1, and an x-intercept of 2/3 0. So sticking with the same scale as before, counting by ones on our x and our y axis, our first line will look the same as it did on part A. And then our second line, we have at 0, -1, 2/3 0. And if we graph this carefully, our lines should look parallel to each other. So if we're looking for a solution, and a solution means intersection, where do parallel lines intersect? Well, they don't. So since they don't intersect anywhere, we would say no solution, because they're never going to have an intersection. All right, so this next section just kind of summarizes what we just talked about. The relationship between the graph of a linear system and the system's number of solutions is described below. The graph of the system is a pair of lines that intersects at one point. Okay, that's what we did on example 2. It means that it has one solution. The graph of the system is a single line. That's what we did on 3A. The system has infinitely many solutions, or you can abbreviate that IMS. Okay, one solution would be a single point, so it'd be a coordinate like x, y. And then the graph of the system is a pair of parallel lines, so there's no point of intersection. That was 3B, so it means it has no solution. All right, so on all of those, we talked about how graphing is not very accurate. We were learning to estimate the solution by graphing because it's not really accurate. However, if we use a graphing calculator, we can get an answer that's very close, sometimes exactly, to the actual solution. So we're going to try using our graphing calculators now to find the intersection point. So here we have this system. In order to be able to put it into our graphing calculator, we have to solve this system for y, because you guys are familiar with the y equals part on our graphing calculator. So we have to solve this so that the y is by itself. So we can substitute it into y1 and solve this one so the y is by itself to substitute it into y2. Now that work has already been done for you on your paper, but in future cases you'll have to do that yourself, where we subtract the 5x and then divide by 3 to get that first one to have a y by itself. Subtract the 4x, divide by -2 to have the second one have the y by itself. All right, so now you want to go to your graphing calculator. Type those equations in to your y1 and y2. Please note, use parentheses when entering fractions. Some of your calculators, when you put a fraction in, it writes it horizontally. If it does that on your calculator, you have to have parentheses around it. So parentheses, -5/3 parentheses, x minus 5, or 2x minus parentheses 45 divided by 2. So go ahead and type that in. If you need to hit pause to stay caught up, please do. Because after you type those in, you're going to hit enter so that you can, or I should say graph, actually. Hit graph. And most of your graphs will not intersect on the screen. If your viewing window is a standard 10 by 10, then the graphs down here are going to be what you see. This one on the left, it doesn't graph on the screen, the intersection. So we need to change it. So if you go to Window and change your X max, your X min, or maybe just your Y min to -20, you'll be able to see the intersection on your screen. And you have to be able to see the intersection in order to do the next step. So again, you may not be to that part yet, so hit pause so you can get there before we talk about what to do next. All right, after you see the intersection on your screen, you're going to use your intersect feature. So you're going to go to Calc, choose Intersect, then you basically hit enter 3 times. Enter, enter, enter. And the calculator gives you the intersection of those 2 lines. So calc, intersect, enter, enter, enter. And then your screen should tell you that the 2 lines are intersecting at approximately 4.77, negative 12.95. If you have any difficulty with getting your calculator to do that properly, please come see me and we can work through it. Most of the time when people get an error, it's because the intersection isn't on their screen. So make sure before you use your intersection option that you have changed your window to see the intersection.